Oh shit. I don't believe I did that. I actually filmed all of that, but I didn't actually put the filming on. Right, so basically this is the array. It's not completely cleaned off yet, because we've got to take the edging off as well. But basically that's pretty much it. Also, I could do with finishing that right back to the metal. You can see now that's the little channel where the thermistor went, which came out. You can see that there's some stuff in there as well. I think that's just the heatsink paste. And this is the actual thermistor. It's still intact, and it'll probably still work if I connect it up, because it's as you can see, it's still there. You can see the connections are still made and everything, so it didn't get broken down. We used paint thinner, basically, that stuff there, to try and get some of it off, because I haven't got any petrol. So what I'm going to do now basically is sit this upside down in some petrol and soak it, and it'll probably take this off as well, which is the glue that was used around the edge. But yeah, and one of these, effectively, this is an equivalent to the original array. So this is an IGBT unit, and this is in actual fact, it's twice the power, because you can see it's FF600 R12, right? The 600 means 600 amps, and the 12 means basically 1.2 kilovolts. It's 1200 volts, and that's how the serial number of this works. Yeah. And inside there, in actual fact, inside there is 6 IGBTs. They're all sharing the same die. So you've got like 3 on this side and 3 on that side, plus the freewheeling diodes are on the die. So each of those IGBTs can actually handle 200 amps, and they go in parallel 600. And but they're laid out in a way, and there's channels around them so that you don't get the voltage fire across. Of course, it's made a single unit. Now, how I'm going to mount it, I don't know. I've still got these things, and they've still got the bolts in them, so we can maybe construct something to clamp it in place. That is the equivalent of the array that it's replacing, effectively, because we've got these are 75 amps each, but they're 600 volts, not 1200. This is a 1200. And so if you think 75, that's 150. That's 300, and the whole 8 is 600. So that's a high side, and this is actually the high side because I've got my original schematic that I did, and you can see that the high side is actually on the outside of both of them. So these arrays here were for the outside. These were all in parallel, apart from the gates, which had a gate resistor on them all. And these were the low side ones, and on this side these are the low side ones, and the high side ones are on the outside and the low sides are on the inside. Yeah, but those would be basically that would be a half bridge, right, and it would be 600 amps, and then you have another half bridge there, 600 amps. So that is just the equivalent, basically. So if you put one of them on there and another one on there, then you would have the equivalent in the same, but obviously that's a lot neater. We don't have all this paste around. You do inside, of course, it's got paste inside it. There, like I say, there's 6. There's actually 6 IGBTs inside there, 3 for the low side and 3 for the high side, and there's 6 freewheeling diodes, and each one of those is 200 amps, basically. So you're handling 3 in parallel here for the 600 amps, another 3 in parallel there for the 600 amps. That's how it's constructed inside, and it's all full of gel and everything. You can take the top off and actually see into it. It's quite nice. But the way the current is laid out, of course, is much better, because you've got your 2 input terminals there, and they've got sufficient spacing so they're not going to arc across. And then you got your 2 outputs, which are actually cross-connected to the same output. Really, you should bridge them across, because they actually have the bus connection inside. It has 2 sets of bus connections to here. So you should bridge them across, really, to get the full current on the output. And you can replace them, although you would need to machine. These are actually bumps. They're actually raised bumps, as you can see. They're not flat, and so you've got a ridge there, And so if you actually wanted to put this on there, you really should machine that down. The other way I can do it is, and I might actually do it that way just initially, is basically to construct a plate that goes on here that will bolt on and then bolt that onto the plate. I might do it that way instead, just so that we can get the conduction that way, because then I can bolt this directly onto the plate and then bolt the plate onto there, and that might give me the ability to just mount it, and then I can use this. Now, as I say, that is a half bridge, and another half bridge on there to put those in parallel would give me the 1200 amps. And so I actually have those two half bridges and just simply connect them in parallel across the bridges. So you have the high side and the high side connection, the low side and low side connection, if it's that way around. Then that would be the equivalent, and that actually would work. And you could use that even in a Tesla which has blown drivers. Obviously, you'd have to have to go through this process of clearing all that shit off and then cleaning it right back to the metal, and then you'd have to somehow construct a mounting, which I haven't got, and do it that way. And you could even have because the thermal has come out, but this actually has got a thermal on it. I think that's the thermal connection there that you could just simply connect directly in, and you've got one on each actually, so you'd have both of them. So you could actually replace this whole array with a couple of these, and it would work the same, because it's the same. Effectively, it's the same power rating, except for these are 1200 volts instead of 600. So you could actually take it up to 1200 volts, except you can't because the capacitor is 450. Yeah. So that's it. That's the plate. That's its construction inside, and you can see that quite well. I'm going to take a picture, and we've got that one I've already got. And this time I did actually record a video. And all I need to do now is get this edging off, basically, and I can use it, or maybe I'll just get it in a bath of petrol upside down, and that should clean all that shit off, and then just really go over it, perhaps with a drill and some polishing or some wire brush. Maybe I need to maybe machine those down. I don't know. These holes actually don't have screws in them. It's just these ones in the middle here, these four, and then you've got four there and a four there, four there, four there, and those would do. And I don't think these holes do anything. I think they actually come through from the other side, because some screw holes, in fact, you can see. There you go, those right through. Those don't, those just go into it. Yeah. And then there's these two here. I don't actually know what these are, but these come through from the other side as well. They've got screws in them, little thin screws. And then I think maybe these ones have got screws. No, they haven't. I'm just feeling the back. There's no actual screw. Might be a screw in there. I don't know. Has that one got one? See it now. Anyway, that's it. That'll do me for now.